Welcome to Networks Professionals.
Welcome to the Explainer. So, if you've ever stared at routing protocols and felt, just a little bit overwhelmed by all the dense terminology out there, well, you're in the exact right place. Today, we're demystifying some absolutely core OSPF routing concepts. We're going to make it simple, clear, and logical by looking at OSPF's designated router and backup designated router. Really, we can just think of this as the corporate hierarchy of networks. And honestly, once you see it through this lens, the whole thing makes perfect sense. Let's kick things off with a pretty fundamental question. How do routers actually share updates without completely crashing the network? Picture this, a massive room where literally everyone is shouting out their status updates at the exact same time. It'd be absolute ear-piercing chaos, right? Well, in a multi-access network environment, if every single router shouts its updates simultaneously, it creates massive, debilitating CPU overhead. It's a huge problem and it demands a really structured solution. Okay, let's dive into this. Here is our roadmap for today. Number 1, the network traffic problem. 2, meet the DR and BDR. 3, multicast communication rules. And 4, the OSPF election process. Section 1, the network traffic problem, multi-access chaos. So before we can really appreciate the fix, we gotta understand the headache. Multi-access networks like Ethernet cause immense redundant communication and CPU overhead if they're left unmanaged. Just think about the math here. If every router has to form a direct full relationship with every single other router on the exact same Ethernet segment, things get terrifying really fast. Every time there's a tiny network change, they would all redundantly share topology info at the exact same time. It wastes valuable CPU cycles and completely chokes your bandwidth with duplicate updates. It's just wildly inefficient. Moving on to Section 2, meet DR and BDR, the management team. To fix the total chaos of everyone talking over everyone else, OSPF introduces a couple of heroes to act as the central hubs. First up is the designated router, or DR for short. This is the primary router managing routing info on the segment, and it receives all link state advertisements, or LSAs. You can basically think of the DR as the office manager. Instead of every employee trying to update every other employee individually, everybody just drops their reports right on the manager's desk. The manager organizes it all, makes sure everyone gets the final official memo, and boom, all that redundant chatter is completely eliminated. But what about a contingency plan? You always need a backup, right? Meet the backup designated router, or BDR. This is the hot standby router that is constantly monitoring the DR. Going back to our corporate hierarchy, this is the assistant manager. They're sitting right there, totally up to speed on every single detail, just waiting to instantly step in and ensure network stability if the manager unexpectedly drops offline. Now, what about everyone else in the office? Well, they're called DROthers, which literally stands for DROther, and these are your standard employee routers. They follow a super strict communication protocol. Basically, they form a full adjacency only with a DR and BDR. So they only have those deep, comprehensive data exchanges with management. With their peer DROthers, they just maintain what's called a two-way state. It's kind of like a polite nod in the hallway, acknowledging they exist, but absolutely no heavy lifting or detailed routing info is exchanged directly between them. And this brilliantly illustrates our next point, Section 3, multicast communication rules, the private channels. So how do they actually pass all these messages back and forth without causing a racket? Let's cleanly contrast how this works. When a standard OSPF router experiences a network change, it shoots an update to the multicast IP address 224.0.0.0.6. Here's the magic trick. Only the DR and BDR are actually listening to that specific address. It's essentially a private, direct phone line straight to the bosses. Then, once the DR processes that update, it turns around and blasts out the final routing update using 224.0.0.0.5, and every single OSPF router listens to that one. So, to put it simply, 224.0.0.0.5 is the company-wide loudspeaker. Employees use the private line to report up, and the manager uses the loudspeaker to announce down. Let's move to our final piece, Section 4, the OSPF election process, choosing the leaders. All right, so how do these routers actually decide who gets to be the manager and who gets to be the assistant manager? Keep in mind these elections happen per multi-access segment, not the whole network, just the local segment, and they usually happen right during that initial two-way state of neighbor discovery we touched on earlier. It follows a very strict, logical two-step framework. Step 1, the router with the highest OSPF interface priority wins. That's a value anywhere between 0 and 255. If there's a tie there, we jump to step 2, the highest router ID, or RID. Let's break these rules down so you know exactly how the promotion works. But wait, before we look at the winners, I want to dramatically emphasize a very special number here, 0. If an interface is assigned an OSPF priority value of 0, that router is completely 100% disqualified from the election. It's basically raising its hand and saying, hey, I just want to be a standard employee. I do not want to be management. A priority 0 router will never, ever become a DR or BDR. But here's the catch. By default, every single OSPF router comes out of the box with an interface priority of 1. So, because everybody starts on the exact same playing field with a priority of 1, the election almost always skips right past step 1 and heads straight for the tiebreaker rule. And that tiebreaker, as we mentioned, is the router ID, the RID. So how is it determined? Usually, it's just the highest IP address on an active loopback interface. If you haven't configured any loopbacks, no problem. OSPF just looks for the highest IP address on an active physical interface. Whichever router has the highest router ID wins the tiebreaker, snags the top job as the DR, and the runner-up takes the BDR spot. So, the crucial point is, OSPF has absolutely no preemption. This is the ultimate unbending law of the OSPF hierarchy. In a lot of tech setups, if a bigger, better, much faster device comes online, it just automatically takes over. Not here. A new router cannot just waltz into the office and steal the manager's title. Once a DR and BDR are elected, those roles are locked in. A new router just has to sit there and wait until the current boss fails or until an admin manually restarts the OSPF process. So let's leave you with this final scenario to chew on. If a brand new router with a perfect, maxed out priority of 255 connects to the network right now, why does the current DR completely ignore it for the management role? Well, if you've been tracking with us, you know it's because of that strict rule of no preemption. It forces stability over constant, chaotic restructuring. Why does this matter to you? Because thinking through scenarios exactly like this is how you truly master network design and troubleshoot why a router isn't taking over when you think it should. I really hope this explainer helped make sense of the corporate hierarchy inside your routers. Keep learning, keep optimizing, and we'll see you next time.
Thanks for watching.